Section 3.8 talks about differentials. This is a topic called differential equations. This is a course, extremely useful, and this is how it works. We start off by saying if y equal f of x represents the derivative, a differentiable function. The differentials of x denoted by dx is any non-zero real number. The differentials, if y equal f of x, and I take a derivative dy dx would be f prime of x. If you think of this as a fraction and you cross multiply, wouldn't dy equal f prime of x dx? So this is what they mean by differentials. So then dy would be f prime times dx. So this is, again, not a big secret. The change in price would be the rate of change times the change in units, because x is units, if you think of y as a price or revenue. So to apply this, it's fairly simple, really. You just need to understand the concept. 4 problems, 14. The function, here's the cost, here's the x value. They say use differentials to approximate the change in cost, revenue, and profit corresponding to any increase in sales or production in 1 unit, in 1x. For instance, on number 13, and they talk about 13 and what that means, and so on and so forth. Then compare this with the actual change. So, in 1 unit. So what they say, if we take a unit, this is going to figure out the rate of change of the cost when you are producing 10 units. They say approximate the change cost x increase from 10 to 11 and see what the exact is and what differentials is given you. Here, go to 16. 11, I meant. And here, go to x equals 61. See the actual and see the differentials. So the cost function on 14. The cost is 0.025x squared plus 8x plus 5. If I take the change of cost with respect to units, that's 0.050x plus 8. If I cross multiply, that is 0.050 plus 8. And now I'm going to elaborate a bit on what that means. And the change in cost, so the cost is changing at a rate of, when x equal exactly 10, at that time, 0.050 times 10 plus 8, and the change in x, we're going to assume that you're going for 1 unit. So if I get my calculator out and I take 0.050 times 10 plus 8, 850. So differential says the approximate change is $8.50 per unit. When you are producing 10 units, that number will change. If I want to find the exact change in cost is actually the cost of producing 11 units minus the cost of producing 10 units. That tells you that extra unit, the 11th unit, costed how much. This is saying when you're producing the 10th unit, at that time when you produce a 10th unit, the cost is changing at a rate of $8.50 for each unit that you produce. If I take C of 11 minus C of 10, that is really 0.025 times 11 squared plus 8 times 11 plus 5 minus 0.025 times 10 squared plus 8 times 10 plus 5. And if I plug this in my calculator, and that will be the exact change. So that's really the change in the cost of producing from 10 to 11 units. If I get my calculator out, and if I take 0.025 times 11 squared plus 8, if I take 11, enter, and if I go by 0.025 times my answer squared plus 8 times answer plus 5 minus 0.025. Oh, I'll get that amount. If I take this and I subtract it, oh, that's not going to work. Okay, what's that number? 96.025 minus, now if I go in and I say let's put 10 in and evaluate, 87.5, the actual change. So this is exact change, this is approximate change. And if I subtract those, what do I get? If I take 96.025 minus my answer, I'll get 8.53. It's money, right? You're going to 2 decimal places. So the difference is it's 3 cents per unit. Out of 850, that's not much of a change. The difference is, differentials give you a very quick idea. This is a lot of work most of the time, for almost any application. So if I go for number 16, now I want to figure out the change in revenue, the same idea. If I look at the revenue function, that is 50x plus 1.5x squared. If I figure out the change in revenue with respect to x, that's 50 plus 3x. Or the change of revenue, differentials, is roughly that amount times the change in x. And we're going to go evaluate the revenue when you are selling the 15th item. So dr will be 50 plus 3 times 15. And we're going to assume you're going for 1 unit at that time. We go for 1 unit because it doesn't make sense to really talk about a fraction of a unit, at least not yet. So if I take 50 plus 3 times 15, the revenue is roughly running at $95 per unit. I thought something was wrong. I made a mistake. That's a minus right there. I was thinking the number is not making sense. Again, that's why it's important for you to make sense out of the questions. Make sure they make sense. And actually, I meant to say a minus. $5. So the change of revenue when you're selling the 15th item is increasing at a rate of $5 per unit. If you want to find the exact is really taking the revenue in selling 16 units minus the revenue. Again, this is a good approximation because you're figuring out how much is the revenue changing when you're selling the 15th unit. You went from 15 to 16, the 16th unit. And if I plug this in my calculator, and there's the revenue, so if I go up there, again, everything on a calculator, if I take 50 into 16 minus 1.5 times 16 squared minus, and if I take 50 times 15, I decided to do it one shot this time, 1.5 times 15 squared, $3.50. So we are off by $1.50. Again, this is always approximate. And how about the demand? Well, the same deal. dp dx is actually negative 0.3x squared plus 900. So the change in price is affected at this rate with a change of units. If I figure out the change of price, negative 0.3, and we're talking about 60. And we're going to assume that's a 1, so we're going to figure out the exact, and that turns out to be negative 0.3 times 60 squared plus 900. Negative 180 per unit. And we'll talk about what that means in a minute. For now, let's figure out the actual change in profit. I'm sorry, not demand. Profit, capital P. That is really the profit of selling $61 minus the profit of selling 61 units minus 60. So nothing more than you plug in this in your calculator, the original equation. So if I take parentheses, negative 0.1 times 61 cubed plus 900 times 61 minus 50 minus 60 units. So negative 0.1 times 60 squared, plus 900 times 60 minus 50. Whoa, something went way off. Let me double check what I inputted. Make sure I input that right. So something must have went wrong. Let's see what that is. 0.1 times 61. Okay, very good. Cube, that's right. 900 times 61 minus 50. And negative 0.1 times 60 cubed. 900 times 60 minus, okay, how about now? We're getting 198.1 negative $198.10. This is at 60. So here, the differential is 180 negative dollars, and the actual is negative $198.10. So we are off by $18.10. Again, those are not exact, but they give you a good idea. Now, to really demonstrate what this means, if a new iPhone comes out, or a new computer come out, or a new TV come out, and you just want to figure out an idea of how much it costs, you say, hey, guess what? The new iPhone came out, and the last one was $1,200. So if you're assuming that, wait a minute, how much is this? And somebody tells you, well, you know, I bought one for 900 on end. They don't have to continue. So you have a good idea now. It's around the $900. That's really what differentials find. The exact value. So if you say the actual cost, differential is actually $8.50. And the actual is $8.53. So you're off by only 0.03, 3 pennies per unit. That's a good idea. It gives you a good idea. Even here, even though you might say, wait a minute, but the differential is saying around 180 and it's really 198, but it's giving you an idea around what number it is. And we use differentials a lot. Now, we're not going to use it to its full extent in this class, but here's one in which you would use and benefit out of it. The revenue of a company selling X units is given by that equation. Use differentials to approximate the change in revenue as the sales increase from 3,000 to 3,100 units. Use differentials. Well, dr, this is part A, dr dx is actually 900 minus 0.2x, and if you cross multiply, there it is. Again, there's a whole class on this. And the change in revenue in selling an extra 100 units around when you're selling 3,000 units is going to be 900 minus 0.2. And x is 3,000 units. And what's the change? dx. You went from 3,000 to 3,000 units. Isn't that 100? So the change in revenue is roughly, and let me get the calculator out, 900 minus 0.2 times 3,000 times 100. 30,000. If I go for part B, so this is an approximation. When you sold 30,000 units, 3,000 units, at that time, for the extra 1,100 units, the change in revenue is roughly $30,000. Versus, if you would go ahead and compare the actual, this to the actual, we call that the actual change in revenue. This is an approximate. This is exact. That's the revenue in selling 3,100 units minus the revenue in selling 3,000 units. Plain and simple. If I plug this in my calculator, I will get parentheses 900 times 3,100 minus 0.1 times 3,100 squared, subtracted from, that's the revenue of selling 3,100 units. The revenue from selling 3,000 units is right there. Oops, forgot the 1, otherwise that could be a 0. Oops. 0.1. Did they put a 0.1 in the previous? Yeah, 0.1. Of course, you could do this quicker if you really want by programming the calculator. By putting the first one, put answer instead. But, it's not, let's take that one. 29,000, $29,000. You know what? Somebody looking at this is not going to know how I got this. This is me showing that I got this out of using a calculator. So as you see, this gives you a very good idea, but it's much quicker on the long run than this is. And your homework, you're going to do 13 through 17, odd, 33, and 35. And that concludes this section.